The diagram below shows a section of a suspension bridge. The top T of the vertical tower, AT, is 14 meters above the horizontal roadway. The suspension cable DT is of length 17.5 meters. The suspension cable CT makes an angle of 61 degrees with the roadway. The roadway section BA is of length 3.5 meters. Calculate the length of the roadway section DA. Now here we need to figure out what is it DA, what is the length of DA. Now notice we have A, now where's DA? Well, DA, so this is DA right here. This is the length DA. And so what we basically have is we're basically zeroing in on this particular right angle triangle. And our goal is to determine what is the length of DA, the same red line at the bottom. And so notice that we already know that this side is 17.5, and we already know that this side is 14. And so we have to use the Pythagoras theorem, which is going to help us. Now, notice that this right here is the hypotenuse of the, C is the hypotenuse of the triangle. So C is 17.5, and A, well, A is 14. And so what we actually trying to find is we're trying to find this length, right? We're trying to find this length, right? DA, and this length right here is a B, all right? And so we have C is going to be equal to 17.5. We have A is going to be equal to 14, and we have B squared. So we have 17.5 squared, we have 14 squared plus B squared. Next, we say what is 14 squared? That's going to be 196. What is 17.5 squared? That's going to be 306.25. Next, we send the 196 over the equal sign, and that gives us 306.25 minus 196, and that equals to B squared. Next, we subtract, and when we subtract, we get 110.25. And when we subtract, we notice that we have 110.25, but that's not the end. We're not done yet. We have to take the square root of both sides because we're trying to figure out what is B. And so this was canceled with this, so we are left with B is equal to the square root of 110.25, and we have that B is equal to 10.5. And so that means that the length of the roadway section DA is actually going to be equal to 10.25 meters. That's the answer to this question. Next, we have to determine what is the length of the suspension cable CT. All right, notice that we have CT right there. So this is CT, all right? And what we're looking at is we're looking at this particular triangle right here. So we're looking at, but we're really focusing on this side, CT. But I highlighted this triangle so that you can know what triangle we're looking at, right? Now, what do we have? Well, let's label our triangle. Well, we have theta, which is 61. And so the opposite side is going to be 14 meters. We also have the right angle right here. And so this right here is going to be the hypotenuse, right? That is the side that is opposite this right angle. And then right here, CA is going to be the adjacent. And so our goal is to figure what is the length of the suspension cable CT. In other words, we need to figure what is the hypotenuse of this triangle. Now, how are we going to do it, right? How are we going to get the hypotenuse? Well, we're going to use one of our trig ratios. Notice that we already know what theta is. Theta is 61 degrees, right? We already know what is the opposite, right? We already know what is the opposite side, but we're trying to figure out what is the hypotenuse, right? So that's the opposite and the hypotenuse. So we have the opposite, and we're trying to figure out what is the hypotenuse. And so we have to use a trig ratio that involves O and H. And so that means that we have to use sine of theta because it has the opposite and the hypotenuse. Now, what is the opposite? Well, the opposite is definitely 14 meters. What is theta? Theta is 61 degrees. That is the angle. And so we have sine of 61 is going to be equal to 14 over x. And we put x because the hypotenuse is what we're trying to find, and that is x. And so we have 6 sine of 61 all over 1 is going to be equal to 14 over x. Next, what we're going to do is we're going to cross multiply. So we say that x multiplied by sine of 61, right? X multiplied by sine of 61. And we have 1 multiplied by 14. But we still have to figure out what is the value of x. So we have to divide both sides of this by sine of 61. This cancel with that. So we get that x is equal to 14 over sine of 61. And so we get that x is equal to 14 divided by sine of 61, which means that x is going to be equal to 16.00695695. That's what x is. And so what we have here is we have that x is equal to 16.01. Now, why did I do this? Well, I round to 2. That I round my answer to 2 decimal places. So I want to write my answer correct to 2 decimal places. And notice that this is 6 right here. And so once it's 5 or greater, we can add 1 to the 0. And so we have 16.01. And that's our answer correct to 2 decimal places. CT is going to be equal to 16.01 meters. And that's our answer right here. Next, our goal is to determine the angle ATB, angle ATB. Now, where's angle ATB? Here we're focusing on this particular triangle. All right. Now, but where is angle ATB? We know that T is right here, right? This is theta. T is here. So let's label our triangle. So this right here, T, angle T, which is theta, is here, and down below would be the opposite. And this is the right angle. So the side that's opposite the right angle is the hypotenuse, and the adjacent side is this one. All right. And so what we have is we have to use one of the trig ratios. But remember, we're trying to find the angle. All right. We are trying to find the angle. Now, what sides do we have? Well, we have the opposite. That's 3.5 meters. And we have the adjacent. That's 14 meters. So we have the opposite and we have the adjacent. And so that means that we have to use tangent. We have to use tan of theta because tan of theta incorporates both of those sides. And so we have the opposite, which is 3.5. We have the adjacent, which is 14. And we have theta is what we're trying to find, right? We're trying to find that angle. And so we substitute 14 over 3.5. We put tan. What we're gonna do is we're gonna take tan, we're gonna apply tan inverse to both sides. And so we have tan theta is equal to 14 over 35, but we're gonna take the tan inverse of both sides. And so we have tan inverse of tan theta, which is gonna be equal to tan inverse of 14 over 3.5. We cancel this tan inverse with that tan, with that tan. And this is going to give us theta is equal to tan inverse of 14 over 3.5. Again, we cancel this with this, and we are left with theta. Theta is equal to tan inverse of 14 over 3.5. 14 over 3.5 is definitely 75.96375653. And if I were to write my answer correct to 2 decimal places, notice that this is 3. And so that means that we cannot round up. So that means that our answer here is 75.96. And so that means that angle ATB is going to be 75.96, correct to 2 decimal places.